Yes, it's better to use this one. It's easier for me. Which way? This one? What can it show?
It's okay now.
I can start. Anna, you are ready? You hear me, Anna? Yes. Well, good afternoon to all of you. I will be your chairman for this afternoon, whole afternoon, for presentation. I'm Jean-Paul Le Guigner. I'm from France. I've been working for networking for about 30 years. And I'm now working for universities in general, not only the University of Rennes, if you look at my badge, in charge of, I would say, coordinating services, infrastructures, in strong relationship with Renater. Renater is a French national research and education network. So I think it's enough for me. You have seen some message on the screen. Please switch off your phone and as well as your PC's sound. Thank you. Well, this afternoon is devoted to peer-to-peer. As I said, we have 4 presentations, and each presentation is about 40 minutes, and we will take 5 minutes for questions. I think Anna hear me. We agreed on this. Okay, so the first speaker is Anna Preston. She is a program manager for international programs for Internet 2. She is working with about 40 international partners, project partners. She manages responsibility for Internet 2 relationship with non-US partners. She is located in the University of Tennessee, Knoxville, where she is working part-time, and she is on loan for Internet 2. But I think Anna will give more details. So Anna, here you are. It's up to you now. Anna? Hear me, Anna?
Yes. Thank you very much, Jean-Paul. I believe it's good afternoon for everybody there. It's a pleasure to be able to participate in this conference, even if it is remotely. As Jean-Paul was saying, I am program manager for the International Program for Internet 2. And what I'm going to be talking about today is really through work that I initiated also being based in Natal, Brazil, where I happen to be, the northern part of Brazil, because as you all know, it's difficult sometimes to arrange this, but I do want to really appreciate that accommodating on everything that has been done to accommodate my request of still presenting this remotely. Well, with that said, I'm going to, if you can bear a bit with the delay between the time I speak and my slides, I'm going to be talking about peer-to-peer. And basically what I like to cover is why care about that. It's created a lot of buzz. To some extent, I think the word itself, peer-to-peer, is a buzzword. And what I'm going to be trying to do in the first few minutes is trying to define what I mean when we talk about peer-to-peer. Give a quick overview of the basic frameworks and provide some advantages and disadvantages, and perhaps illustrate some models as well. I also would like to cover a few minutes to talk about the convergence of peer-to-peer and grid computing. I think this is really interesting and also very important. While doing that, I will also start highlighting some of the issues and challenges that come up from some peer-to-peer frameworks and make an attempt at defining what the problems are. And I also would like to say that many of the presentations that will follow mine will go a lot more into detail into some of these specific issues and challenges. And I highly recommend staying for the presentation because they really go into some fantastic detail into defining some of these issues and providing case studies and examples. Finally, I will spend the latter part of my presentation on some perspectives on peer-to-peer and the advanced research and education networking community. Of course, I'll have to, from where I'm at in the community here in the United States, I will provide some quick highlights on the approach peer-to-peer here in the United States and in the Internet 2 community. And I'll give a quick update on the recently created working group within Internet 2 and provide just a quick update on the most recent activities. And then finally, I'll have some final observations to make. What do I mean when I say literal peer-to-peer? I'm sorry about this. My slides keep on having a life of their own. What I mean by this is that if we talk about peer-to-peer in its most simplistic view, at its very basic, and peer-to-peer is not a new phenomenon, nor is it a new technology whatsoever. One could argue that it has been intertwined since the inception of the Internet. For example, in 1969, we see a first peer connection attempted between the ARPANET and the different independent computing sites. This, just as some background, between UCLA and Stanford University, with the first attempt being logging, as one might suspect. So in the purest sense, that we can call that a peer connection. That logging, that first instance, incidentally caused a system crash. That was interesting. Of course, then we see through the 70s and 80s the advent of applications as Usenet and DNS, and which exemplifies some of the aspects that we see in peer-to-peer applications today, those being decentralization and limited central control. Of course, in the 1990s, we see the Internet explosion, and through the latter part of the 90s, we see applications like ICQ that, to some extent, also illustrate some of the aspects of peer-to-peer, because ICQ allow for end-to-end decentralized communication and also taking advantage of the endpoint resources. So then we have the turn of the century, and we have this application called Napster. I'd like to show this cartoon as a little bit of humor, and I hope, sorry about this, it keeps on coming. What I want to illustrate is that here, if you can read this, I hope it just shows quick humor on the genie out of the bottle, and perhaps how Napster brought up a lot of the gave a reality check to the recorded industry regarding distribution systems. But what I want to highlight here is that the big application Napster came and went in less than a couple of years, but it certainly has created a lot of buzz, and of course it put a lot of buzz also to the word peer-to-peer. So, like I mentioned, 1999, universities are the first environments to hear about Napster, and then by 2002, it's gone. Of course, through those years, as we have moved on to 2003, the applications within this space for file sharing have, of course, continued to emerge and seem to have be a lot more predominant now. I believe that one can say that the big rush in these past few years has been, to some extent, to find the next big thing in technology with regards to peer-to-peer. What would be the next Napster? I'd like to just make a remark here that I think Napster per se is an application, and sometimes actually, when I'll explain a bit of the model, it has some aspects of a peer-to-peer framework, but it's not necessarily a peer-to-peer application in the purest sense. But the remark that I want to make is that Napster was more of a social than a technical phenomenon. As I mentioned in the previous slide with the cartoon, that takes advantage of resources, whether these are storage cycles, content, human presence, etc., at the edges of the internet. So with that said, let's cover a little bit of the basics. In the simplest form, peer-to-peer, as you can see, is just a point-to-point connection. You see, what I like to define would be three models primarily. The centralized model, which I will illustrate with Napster. The decentralized model or framework illustrated by applications like Nutella and Freenet. And then what I'm going to call controlled decentralized models, hybrid models that have aspects of centralized and decentralized systems. Applications like Kazaa and Groove tend to illustrate this framework. The primary differences are basically, of course, they each have components like client and servers, in some instances servants. But the main differences is how information is shared and how much information is shared. And both of the models have advantages and disadvantages. So we started a bit with the centralized model with Napster. Napster uses centralized servers to keep a catalog of available files. I should say used, but let me talk in the present tense as if it were an application, just for illustrating the purposes of how this framework works. In a centralized peer-to-peer file sharing system, a user will submit a request or a search for a particular file. Then the server will then create a list of files that match that search request and will respond with a list of those people or places where it will respond with a list of the available files that are available for download in its central index, if you will. Then with this, there will be return messages of what users or what endpoints will have these available files. And then the requesting user can establish a direct connection, an HTTP link, with the individual computer that currently possesses that file. The download of the files actually takes place directly from one network user to the other. Okay? Without the central server, the network does not function. The size of these frameworks can vary from single millions of clients and, of course, a central server. And because of this centrality, whatever entity controls the central server also controls the information. So that's a bit of the centralized model. If we look at decentralized frameworks, clearly exemplified by Nutella, this varies a little bit, quite different. But in a nutshell, the way this framework works is that a user will start with, say, computer A, as you can see in this graphic, and will attempt to make a connection, announce that it's alive, to be making a search request, initiating a first layer request to computers B, C, and D. And then in turn, of course, then these will also pass on the request to the next layer of connected computers, and so on. I should mention that as those computers continue the pattern and announce to the computers that they are connected, this doesn't go on in an infinite manner. In reality, there's a limited time to live constraints, which are just the number of layers of computers that the request will reach and how far this goes. This is, otherwise things will keep on going forever. So once this happens and it reaches that limit, there will be a reply from whatever endpoint identified the request that was being made that matched this. And then the file is located and a response will be sent to the originating computer that originated the request via the same pathway. And then, of course, the file is then downloaded by A, making a direct connection to that endpoint that identified the request from the originating computer. The Nutella model, as you can see, enables file sharing without using servers. And of course, there are no servers that actually directly serve content. So this is in a bit a way of, I hope in a very basic fashion, explaining how this model works. This is perhaps a little bit more of eye candy, more elaborate views if you want to think of how the Nutella network could be visualized. These are somewhat out-of-date graphics, but For visuals, you can see that the Nutella network becomes an intermath web of connections and network endpoints. Another decentralized example is Freenet, which is somewhat similar to Nutella, but a little bit different. As a file passes through this vine-like framework, the file will make a copy of itself at each endpoint along its route. And this actually, what this produces is that the most popular requested files will also be the most copied files, and will theoretically be the easiest files to obtain. This is a completely open source, open project. The vision of this project is to allow information, whether it's copyrighted or not, but any kind of information to be distributed anonymously and in an untraceable manner in a pure peer-to-peer framework. As another example of a decentralized framework, Freenet, and again shows eliminating the reliance on centralized entities that could be potential points of failure. So that's a bit on the centralized and decentralized models. Some pros and cons are listed there. I already highlighted some of these. In a quick nutshell, you can see that the centralized model seems to have a way of perhaps producing more effective and comprehensive searchers because of the indexing capability within one entity, that being the server. In the decentralized models, finding things are not necessarily that easy. But you can also see aspects of control. In decentralized frameworks, access is not control as it is in centralized frameworks. And of course, both of them have the give and take advantages and disadvantages. With the decentralized model, I like to highlight that some of the disadvantages, as I mentioned, are scalability, the searching capabilities, but also a lot often in some of these systems, particularly the file sharing ones, you see this thing called freeloading, where you see a lot of consumers, but not a lot of producers of content. And I think you're having problems with seeing my. I'll continue. Okay, perfect. I'll continue to move on then. When I spoke a little bit about this decentralization, actually the frameworks, I mentioned there's a third model, which is the hybrid model. These will be a model that has characteristics of both centralized and decentralized frameworks. A user's computer or an endpoint may act as a client, a server, or a servant, a computer that can act both as a client or a server. And an example of this framework would be an application like Morpheus, although I believe Morpheus is not very much in use these days, but I like to use it as an example of a hybrid model. Morpheus, as an application, just as background, was about the full gamut of information, not just MP3s or music files. You could also have support for audio, video, image, document, and software. Some aspects of Morpheus that made it a little bit more sophisticated were, for example, the use of metadata via XML tags to describe contents of the information and the data files, which also made it a lot easier to find things. It also included technologies to improve download performance so that you wouldn't be running into issues like incomplete file downloads, something that tends to happen quite a bit with Napster and Nutella. Morpheus included technology that allowed for example, if there were loss of connectivity or the potential for incomplete file downloads, Morpheus implemented a sort of technology that allowed to automatically resume downloads because it contained different indexes of different places where the same file download could be found. Another technology was, of course, this the ability to have it had a more sophisticated search engine that allowed to find a lot more than one active peer that had their requested data file. So this allowed, again, complemented with the technology of being able to download from several places where one were to fail, made Morpheus a little bit more sophisticated than Nasser for sure, but also provided some of the advantages that Nutella does not have. So the following graphic just illustrates a bit more what I just talked about. And the framework, I'm not going to go very much in detail. I have some notes included in my presentation, which you can look at. But again, Morpheus is an example of sort of controlled decentralized framework by way of these supernodes. And another example of sort of hybrid model is Group, the collaborative application specifically designed for the workplace, but also to provide a sort of, for businesses, for the business sector, some of the advantages of a peer-to-peer environment with internal controls built in. This application includes file sharing capabilities, instant messaging, Blackboard, and a secure environment too, which made it very appealing for the business sector as a way of communicating in a secure fashion, but allowing for a more efficient workflow, will, and collaborative opportunities within a particular business entity. So with that, I will conclude a bit the part of my talk on the basics of the frameworks. Moving on a bit, if we now want to move into, well, what are the things that fall into these models? It's difficult to sort of categorize what will fall within these. So I'd like to actually offer perhaps a different way of cataloging what falls into peer-to-peer, or perhaps some things that have aspects of peer-to-peer, but perhaps it's, I think, maybe better to put depending on the application or the function that they serve. So as you can see in this slide, I like to think perhaps then of the functions as file sharing, or content distribution, or instant messaging, or distributed computing, which is not peer-to-peer, but there are some similarities in some of the functions. And also, in terms of collaboration or group work, also in terms of the development of tools and suites, that the frameworks to develop things that there are. So I'm not going to make an attempt to catalog everything that will fall under these with the word peer-to-peer also in them. I take these sort of application and function area taxonomy from the O'Reilly peer-to-peer directory, which identifies a lot of the companies and projects that fall into these function areas. Another way perhaps of classifying peer-to-peer could also be seen as making a sort of matrix, if you will, between the function and the audience that they serve. So if you're looking, for example, in the research sector, it's perhaps a lot easier to then catalog some things within, in research for the business community or research for the consumer community, but also in the commercial sense, what will fall for each of these audiences. So I will recommend taking a look at the O'Reilly classification because at least it illustrates a bit more that some of the characteristics that make some of the applications that claim to be peer-to-peer fall under some of these functions. So what I like to talk about now is just what do a lot of the things that get called peer-to-peer, what do they have in common beyond the definition and the pure and literal definition of peer-to-peer? What we see are applications where you see endpoints on the internet exchanging information and form communities. You see a new level of collaborative and workflow opportunities. Most importantly, you see resources that are located at the edge. And these resources can be a variety of things: content storage, computing power, bandwidth, human attention, et cetera, but how these resources can be better utilized and accessible in real time, which gives you a sense of presence. And each of these resources, to some extent, has its own autonomy. So there's autonomy at the edges. to a bit, again, looking at perhaps the way peer-to-peer at its inception with the beginnings of the internet, how it was, resources at the end, connections end-to-end. A few words just that I want to clarify also. In my view, peer-to-peer is not distributed computing. They're two different things. I do think, though, that there are some similar challenges and issues that stem from the sharing and taking advantage of resources that are available at the endpoints, and how that these resources can be harnessed, for example, for computationally intensive problems. So, and that's clearly what, in some instances, distributed computing does. Some examples, particularly with some of the interesting attributes that come up when you're thinking about a peer-to-peer framework include applications like SETI at home, and we've now seen a variety of things that have come out, 5/8 at home, Genome at home, and et cetera, et cetera. Talking about SETI at home, it's often cited as a peer-to-peer application, but it's not a peer-to-peer system at all. It's more of an inverted client-server system, but that also takes advantage of harnessing the power of many endpoints to solve problems. I'm not going to talk very much about these applications. Perhaps what I want to just highlight is that these applications, to some extent, have highlighted how you can use the internet, the PC internet computing world, to grow to mega computers, but taking advantage of many, many endpoints located at the edges. Okay, so with that distinction now, I am going to move now to talk a little bit about peer-to-peer and grid computing, and what I also think is the convergence of these. I have taken most of my material, I have to say, from a fantastic paper written by Ian Foster and Adriana Iamnici from Argonne National Laboratory. I would definitely recommend reading this fantastic article, because it really highlights what the issues are, but also gives some really good definitions, and provides a view that there are a lot of commonalities in these technologies, and a lot of pros and cons on peer-to-peer, but how grid computing could actually be interested in looking at some of these aspects. So some of the commonalities that are stated in this article are, one of them being the pooling and coordinating use of resources within distributed or virtual communities. And another big commonality is that both peer-to-peer and grids are constructed as overlay structures that sort of coexist, but need not correspond to the actual structure that they're over. So these structures sort of coexist in a similar way. So some of the definitions, I already stated a bit how I'm identifying peer-to-peer as the sort of class of applications that takes advantage of resources. Grids are different. Taking on Ian Foster's definition, grids are more shared environments implemented via deployment of standards-based and a persistent infrastructure that then supports the creation and the resource sharing within distributed communities. The resources in grids, which would be also computer-stored sensor software applications and data, are also connected through an internet and are owned by various administrative organizations and shared under sometimes very well-defined, very well locally defined policies. The definition for the organizations or the domains, if you will, that get put under a particular set of rules are called virtual organizations. Another aspect very important to grid computing is this middleware layer. Middleware software to provide the basic services for security, monitoring, resource management, and for providing the control of those defined policies that sort of overlay a particular virtual organization. So going on to the next slide. This is a bit of a matrix where I try to, building from what's in this article, build a comparison between peer-to-peer and grid computing. One dramatic difference, as we can see with peer-to-peer communities, one could argue, seem to develop rapidly via not very sophisticated services, but indeed very popular services. In grids, we're actually talking about very sophisticated services and applications, which could actually, in early grid applications, one could say, connect very exclusive small number of sites into collaborations that could be engaged in very sophisticated scientific applications. As a result of this, grid computing has evolved into being something a lot more sophisticated and secure because of the nature of the resources and the things going over on these resources. In a peer-to-peer environment, we see, one could argue, unstable environment that somewhat drive the design requirements. I mentioned the different models and frameworks. You see environments that are not necessarily very stable. In grids, you need to have a lot more stability. And not only that, as I mentioned, you're dealing with sophisticated services and sophisticated resources and data. And the scaling in grid computing has to also be a lot more sophisticated. You have to think on issues on autonomic configuration and also pay a lot of attention to the management issues regarding these services. As we see now in grid computing, a lot more interest in commercializing some of the aspects of grid computing, but also modern grid communities. This is an issue on the scalability and also creating and operating the required infrastructure while dealing with the issues around policies, issues around trust, accountability, and et cetera, et cetera. As a result, grid computing also, you tend to have resources that tend to be more uniform, a lot more powerful, more resource intensive, and perhaps one could also say a lot more regulated, but perhaps also better connected than in peer-to-peer frameworks. In grid computing, you also have a very explicit core-based, if you will, architecture. Recently, with the open grid services architecture that's being put forth, you have a core architecture on which it's hoped that all the services would adhere to and have a standardization, if you will, have a set of standard interfaces and behaviors. When you talk about peer-to-peer, we're not necessarily seeing that common core base to build services. In fact, the integration of resources is done via perhaps many different protocols, and sometimes designed to provide very specific vertically integrated functions, which can vary from one application to another one. In peer-to-peer, although we're seeing some promising platforms to create this core base, we still do not see a standard service infrastructure. As a result of that, there's not a lot of adoption and not a lot of interoperability in between some of the applications. So with that said, as you can see, I already started touching on some of the challenges and the technical issues for peer-to-peer. What I'd like to say is that perhaps there's also a lot more challenges that emerge for peer-to-peer applications. I already mentioned some in the when talking about the architectural frameworks, what scales, what architecture can truly give that vision of end-to-end. When we're talking about resources, and here
5 minutes, Anna, please. 5 minutes.
All right. We see a lot of challenges. My colleagues, which will present, will go a lot more in detail about the security issues, for example, and also the resource management issue. In terms of security and also trust and trust relationships, peer-to-peer seems to have also a lot of challenges ahead. because we have, again, how does a content provider establish a level of trust in a peer-to-peer framework? And how do we know that people will follow the distribution rules? So, and then I also mentioned that some perhaps of the main challenges involve also the lack of standards. There are different ways that different companies are going at trying to come up with this core base of interoperability. Juxta, the project Juxta, is one that, in my opinion, shows quite a bit of promise as an initiative that would allow existing and future computing platforms of all types and sizes interact as peers and to also provide that core base. And of course, with peer-to-peer, particularly with the function of file sharing, we clearly have seen that the copyright issue brings a big challenge in that upper layer. Here in the United States, as you probably have heard at universities, there's an agreement with universities that universities are responsible for informing their constituents, but not to police them. And there's a fine line when it comes to peer-to-peer and also the utilization that many universities are seeing on their campuses. So talking a little bit more about that, there's still many, many different things and vehicles that universities are using at dealing, if you will, with this challenge that peer-to-peer puts forward. From the blocking to not blocking, universities continue to look at ways of metering, managing resources, and doing a lot of things and techniques for deploying lots of special purposes, equipment and things, thinking about models, about how to accommodate a fair usage resource sharing model. In any case, peer-to-peer has clearly added at this layer many, many headaches to universities and continues to do so. Now, finally, what I want to talk about is just what's Internet 2 doing in this space. You may have heard me mention at the last RENA conference, within the Internet 2 community, we have had a series of panels and walks through many different meetings, which culminated last year, January of last year, into the first workshop that we had within the higher ed community to explore this space. I would definitely recommend you to go take a look at the website for the excellent presentations and the summary of the workshop. But the outcome out of this workshop, which I see as very critical, was the creation of a working group that currently falls under the Internet 2 End-to-End Performance Initiative. I have listed some of the recent activities and project areas. I'm glad to say that the working group has actually started doing quite a bit of stuff and creating some specific subgroups that are looking at not just trying to identify applications for the research and education community, but looking at issues around security, resource management, of course, with the bandwidth as a resource, and also as a clearinghouse for information resources. The next slides just have a bit of what has been identified within the group. There are some important work and testing that's going on right now with particularly two applications, and one that's really interesting is with Lionshare, which is the Internet 2 community and a few universities which will be working on trying to develop an academic peer-to-peer system that could also be dealing with some of the challenges. So, in conclusion, I think peer-to-peer still has a long way to go, as I mentioned, with the challenges, but we're seeing a lot of stuff happening in this space. We see, as I mentioned, an interesting convergence from peer-to-peer with grid computing, and also I would like to say with web services, where peer-to-peer is looking a lot more also, one would argue, as web services convergent into a single category. We see more standards and work emerging, and this should be very interesting. I think companies are going at it in different ways, but it'd be interesting to see what transpires this year. And finally, I like to state that I think the Internet 2 and also the global advanced networking community also presents some very good opportunities for a good testbed, I think, for the basic research on some of the aspects of peer-to-peer. And I think it's going to be very interesting what we can do in this space. And I believe there'll be some presentations of some applications that are being deployed in Europe that are actually have a peer-to-peer framework. But I think peer-to-peer is a lot more than just the technology, like I mentioned. It's also a social change, and what we're seeing is a new paradigm in particularly the younger generations with the social aspect that I was talking about. So many challenges remain, but also challenges are opportunities. So my final slide has reference and bibliography on some more resources if you're interested. And if you have any questions, please feel free to send me an email. There's also, as I mentioned, a peer-to-peer working group with the Internet 2, and I will encourage you to contact the chairs if anybody is interested in participating in any of the activities. Thank you very much, and again, I'm sorry I'm not there in person to give this talk. I had a conflict that came up which precluded me from being there, and instead I had to be here. But I do appreciate your attention and your patience with the technical details.
Thank you very much, Anna. So we did it again this year. This year it worked well. You covered a large number of subjects and issues. I think these are the basis for a few questions. We have a few minutes for a question. Microphone, please, if there are questions. Questions? Well, I had one question, well, perhaps a worry. I'm always trying to identify what is the frontier between grid communities and peer-to-peer communities. I think I'm wrong. I mean, there certainly is no frontier. And you almost gave the answer at the end of your talk, because what you said is that the peer-to-peer initiative is not a technology one. Well, it's at least not only technology, it's also a cultural change. Is it correct?
That's my sense. I think if you had asked me maybe years ago, I was one of I could probably be quoted as saying that peer-to-peer applications in the purest sense were going to be the killer applications. But now, 2 years later, I think what I see is that I probably want to say grid computing is what's revolutionizing things, and there are some interesting things that stem from peer-to-peer that have some applicability to and very interesting things for grid computing. But I do think that there are some interesting convergence issues there. And I was glad to see the paper from Ian Foster, because he very well states some of the very clear advantages of peer-to-peer frameworks and how those can be adaptable, if you will, and the work that needs to be done to include those in grids.
Okay, thank you.
As you were saying, I see peer-to-peer in the purest sense more as a social thing.
Okay, thank you. Question from the floor? Any question? Yes. Sir.
John Martin, I enjoyed your talk. I just wanted to draw a contrast and get a comment from you, because on the campuses, I'll say in the UK, peer-to-peer is often thought of as synonymous with copyright infringement, possibly the purpose for which the software is felt to be designed. Whereas the grid community, it seems to me, when you look at the grids and the middleware, it seems to me a construction in which respect of copyright and control is built in the design aims. Would you just like to comment on that?
Hi, John. Good to see you. Yes, and I think that's think as you were stating in grids, you clearly see that layer that provides a sophisticated level of policies, if you will. And that has been, to some extent, lacking in particularly the peer-to-peer file sharing, if you will. And as you pointed out, that then brings up all the upper layers. I think it would be really interesting to see if more work has been done in the development community for the peer-to-peer applications to see how there can be perhaps a more entrusted level of control there. On the other hand, we're dealing with the applications that tend to be the ones used for the file sharing aspects don't have a lot of thought being given to that. And in fact, they point out, so it's a sort of interesting thing. What we do see is that perhaps the distribution models are having to change, and maybe maybe what we need to think is better of new architectures for resource management. I don't know.
Thank you. One last question? Yes, last question, please.
Nick Skelton, University of Bristol. Have you got any comments on Direct Connect as a model? Smaller, decentralized, but separate networks.
I'm really sorry. I could hardly hear your question. Could you repeat it, please?
Yes, of course. Is that better? Have you got any comments on Direct Connect in particular?
Actually, I have to be honest with you. I haven't used it, but I have heard from colleagues that they actually think it has a lot of interesting aspects. I'd be more curious actually to hear if you have you used it? What is your opinion? I'm sorry, I have not really researched that.
Okay. Another question? No.
I think that's okay. Thank you. I think we need to wrap it up in terms of time.
Yeah, we are. Okay, thank you again, Anna. And I hope that next year, if you are to give your third presentation, which will be better again, we will be together, me or other people, for the next Terina conference. Thank you, Anna, again. And